Okay, guys, so now we have lines crossing inside of a circle, specifically chords. And so the relationship here is that when these cross, if I multiply this blue times this red, that product has to be equal to the purple times the green. So I'm going to try to be as consistent as I can here with the colors. So essentially, if I multiply ED in green times CE or EC, I'm going to be going out from that intersection point each time. So the green times the purple needs to equal the blue times the red. So I'm going to do EA times EB. The relationship here is that when two chords intersect inside the circle, the product of the parts of one chord is equal to the product of the parts of the other chord. Okay, so parts is going to go on both of those lines. And the parts were created by the intersection. So once we put this into practice, hopefully, sometimes my students think the numbers make it make more sense. So essentially, if I'm using those colors again, blue and red will go together, and green and purple are going to go together. So that's going to set up my equation. So I'm going to have x times 15, probably should have had 15x, but that's okay, is equal to 9 times 10. So cleaning that up a little bit, that gives me 15x equaling 90, and dividing by 15 on both sides gives me x equals 6. So again, the relationship is that the parts that make up one full chord, you multiply together on both sides. Maybe pause the video and see if you can set up the next one on your own. Hopefully you got a chance to try it. And this gives you, if I do the colors again, red and blue go together. And then green and purple will go together. And again, this is true when we have intersections inside the circle. So we've got 8 times 5. And that is equal to 4 times x, giving me 40 times 40 equal to 4x. Dividing by 4 on both sides gives me that x is equal to 10. Now the next situation we're running into does not have that intersection on the outside. On the inside. It is now on the outside, and specifically, it's 2 secant lines. So the relationship here is that we're going to do the whole external times the internal. Again, we're going to do the whole line times the external. Okay, so for both of those, I'm going to do the whole line is ED, and just the external is EA. So that whole line again is going to be EB, and just that external is going to be EC. Okay, so if I have to set up this equation, it's going to be EA times ED. Again, just to be consistent, I'm working out from the center, or not the center, the intersection. That's not necessary, but just trying to be consistent. And then EC times EB. Again, the inside, maybe if I did that in purple, that would be not relevant right now when we're setting up our equation. You might need it to solve for parts of it, but right now in our equation, it's not relevant. So if we put it into words, we would say if 2 secant segments intersect outside the circle, like this situation, the products of the lengths of the blank segments, so of those whole segments in blue, and their external parts, those external parts are going to be equal. Okay, so hopefully we can see this at play in just a second. So these both have internal parts labeled, so my life's going to be a little bit harder than normal. Okay, so again, it was the external, or the whole times the external. And so that whole side there in blue is going to be 14. And just the external is 6. So again, try not to get confused by the addition there. The whole of the other side is 7 plus x. And the external is 7. So that will give you 84 from the 14 times 6. And then I'm going to distribute the 7 to be 49 plus 7x. Now it's just our two-step equation. I'm going to subtract 49 on both sides and get 35 equal to 7x. And dividing by 7, I get x equals 5. So again, I'll label those externals in green. Down there. And the holes are in blue. So if the externals are in green here, we're doing 9 times the whole. So 9, I'll be consistent. The 9 is green times the whole thing, which is 9 plus x. And then the 10 is the external times the whole thing, which is 18. Okay, giving us 180 and 81 plus 9x. Solving our two-step equation, we're going to move that 81 to the other side and get 99. Dividing by 9 on both sides, we will get 11. So that is the situations when you have internally intersecting lines from two chords and externally intersecting lines from two secants. Stay tuned for one more video about the secant line and a tangent line intersecting on the outside. The relationship changes just a little bit.